Hello, hello. Looks like I'm trying to resolve an issue. Says I have to sign into my chat, but I've never had to sign into my chat before here, so uh let me see here. Oh my gosh, two-step verification. Hi guys, sorry about this. I'm just uh signing into, looks like I had some updates on my oh my gosh. Something has definitely changed. How funny is that? See here. Oh, how funny is that? So did YouTube change, or did Stream Elements change the the chat windows? Cuz now my chat window shows my whole YouTube page. Oh my gosh. Okay. Sorry guys, I have never seen this before. Um I have a lot going on today, so I figured instead of trying to just record and release videos one at a time, that I would just jump on live for you guys. So I'm not sure, is this live still? I'm not sure. Am I live? Let me check. Let me check. I'm just checking my delay here because I looks like I can see my video at the same time on my chat window. So uh hold on guys. Give me just two. There we go. Okay. So it looks like I am live. All right. Hey, thanks for letting me know. I know this is an unannounced live stream here. I do apologize for that, but I have been so busy with amplifiers for competitions that I'm having a heck of a time getting videos recorded and edited and uploaded. So I have a couple here that I just thought I'd go over real quick. This is a DC audio 2K. Just a standard DC audio board. And this is where I decided I just was going to jump on live. I don't show any shorted transistors. I don't show any shorted power supply transistors. I don't show any shorted output transistors. So I honestly don't know the fault of this amplifier yet. But what I did notice before I even slid the board out is this potentially, I mean, sorry guys, it's kind of hard to see, but right down in here there's a resistor that goes to the drivers for the power supply. So I'm thinking this has been shutting down from a power supply issue. But let me flip this over and show you guys what this is doing on the meter. So again, I was looking at the power supply drive transistors, the pre-drivers is what I call them, pre-drivers. I don't know what the technical term for them is, but they're pre-drivers. So the drive comes off the card, goes to the pre-drivers then drives your output transistors. So this has been worked on before. And the problem with this is whoever did this work did not clean up the carbon. And I have said this over and over numerous times on my videos. Carbonized PCB is conductive. There's just no ifs, ands, or buts about it. If it's black, it's conductive. It turns into a carbon, and carbon is conductive. So you'll see in my meter, my UT, my UT61E there is up upper right hand corner. Hey Damon, hey, good to see you here. Oh, you bet, Damon. Yeah, no problem. Thanks for dropping in though. So again, the previous tech, they replaced the pre-drivers, but they didn't clean this board out. So if you look at the meter, and I'm not touching any traces, I'm literally just touching two areas of the PCB about, probably about a centimeter apart. And I'm just going to touch these two areas right here. And you're going to see on the meter, oh, you have a resistance reading. Sure, it may be, 40 mega ohms, but again, I'm a good centimeter apart. Probably 2-ish millimeters. But as you can see, I'm down to about 35 mega ohms on the PCB itself. And this is not touching any traces. Again, this is just literally my probe touching two areas of the PCB. So this would really lead me to the point where saying, well, if they would have cleaned up their carbon, the power supply would be a little bit more happier. So here we are, they were down to 21 mega ohms. So the PCB, when it burns up like this, has to be cleaned out. It's got to be removed. All this black carbonized board that you see right here has got to be removed. You will, if you have a business in this and you don't clean this up and you send it back to the customer, I will bet money that it's going to come back to you. So this is probably going to be the reason why this amplifier is in for repair. It'll probably start just fine. That resistor that was burnt here is probably not going to make the drive very happy. So, and I can almost go all the way through this PCB right here. Oh, and there it is. So there's a hole. There's a hole right in the middle of that PCB. So that's conductive. And for you guys that work on these, if it's conductive, it's got to go. Hey, DJ Bell. Hey, thanks for dropping in. Thank you, thank you. I do appreciate everybody's support on this channel. It has grown much larger than I ever thought it would. So I do thank you all again. And I thank you guys for all your patience. But I've been trying to get videos put out, but I have 2 car amps, 30Ks that just came in. I probably have 16, 17, 18, 19. I have 19 amplifiers in line to get done. So, yeah, just as busy as can be. And of course, I'm here to answer any questions too, if you guys have any. So, I don't have any shorts, but I do have carbonized board. So, what I'll do is take the very fine point tip of the tweezers and dig out all this carbonized board. And there's a pretty good size hole right around these transistors here. And you can tell when you're in good board, it'll start to turn a kind of a light brown. But if it flakes off and it sounds crunchy, then it's carbonized board. So again, this is a DC Audio 2K. And I'll just use my trusty Q-tips here. Isopropyl alcohol is going to be your guys' best friend. Keep the areas clean. I've had people tell me that I can use a toothbrush and all that. Well, I do have a toothbrush. I just I don't know. I like the meticulous nature of a Q-tip. So, and I'm gonna dig this board out all the way around the legs of this transistor until I don't get a reading. Yeah, so as I actually get down, that's probably because I do have some isopropyl alcohol. This carbonized board will actually soak up that alcohol too, and it'll show as being more conductive, but it does evaporate pretty quick. So 1K, you're going to read 1K because you have a 1K pull down resistor. And then what I might do is I might go ahead and power this up and see if I have any. You'll see it on the scope. You'll see if you have any carbonized board around. You'll get some ringing. You'll get some just odd signals on your scope when you have something that's conductive like this. It could be from some inductance. It's not supposed to be there. Typically ringing, or the square wave is not going to be very clean. There it is, and that board is dug out all the way around that center leg, all the way through the board. As you can probably hear it. Sorry if you guys, if it sounds like fingernails on a chalkboard. But I want to isolate that transistor from the other transistor. This side here it's a little dark, but it's not dark enough where it's burnt, so it may be okay. So that was my Facebook Marketplace. I'm new to that Facebook Marketplace stuff, and got all my spare amps that I have Not all of them. I got several of them up on the Facebook Marketplace. All right. Hey, Mike. Hey, good to see you here. I can send you more. No, you know, I've got amplifiers that show up every single day, and I have been extremely busy with repairs. But you know, I'm here for you guys. If you guys need an amplifier repair, if you got questions or anything like that, I'm always more than happy to answer them. Whew. Boy, this got hot. There's a resistor right next to this capacitor right here that actually melted a little indent right in the side of the capacitor. Oh, that capacitor is going to have to come out. I can see that this is going to be, so this will be a power supply pre-driver rebuild. That's what this is going to be, because there's a resistor right in between the driver and the transistor down in here, and that resistor is melted into the side of that capacitor. So that's a 105J, which I carry capacitors. Easy repair. Again, I don't have any shorted power supply transistors. 1K. What of our gates? Our gates are 47 ohm gates. Yep, 47 ohm gates, and they're probably going to be a 1K. Let's see here. The resistor is so burnt, it's kind of hard to see. What's going on? So it is 1K pull downs. Yeah, 1K pull downs. Let's see here. 1K. That's a toasty resistor down in there. And 1K. So it may actually start. Yeah, thanks, Mike. Yeah, you know, this was an unplanned live stream. I was gonna record a video on this, just explaining again that carbonized PCB needs to be removed, and I figured, I'll just go ahead and fire up the camera and just go live on this. I do have a Pioneer, I think it's a 9601 that I got also, I'm gonna get over here on the bench, and we're gonna see what's going on with that. Oh, hold on. I gotta readjust my chat window size here because I can't read the whole thing here. Oh, see here. Can you explain the 3-terminal connection on the tar amps 4-channel amps? I understand the connection, but what's happening inside? Is that floating ground? No, it's not a floating ground. So they're using a common. They're using a common. So the middle common is your ground per se, and then you have 2 channels that share that common ground on those 4-channel amps. So you'd understand them more if you open them up and flip the board over, and then you can follow how the board itself functions just by how it's put together. But it uses that common ground for both channels. Oh, yes, Damon. Oh, those 4080s? Oh, yeah. Yeah, I don't know if you guys caught that video. For all you amplifier repair techs, you guys need, if you deal with older amplifiers, this is what you need. This is the HIP 4080. 4081 test board. I scored this really cheap off of online sale, and it's excellent at testing those 4080s. Of course, I designed the circuit here that drives the 4080. But this is what you guys need. And I think those are 200 and some odd dollars on Mauser. You can still get them, but they're super expensive. Just like the 4080s, you can get them, but I guarantee 95% of them will be fake or damaged. That 5%, a few of them you're going to get that are they're actually 4081s, so they're just marked 4080s. I spent a lot of time last year getting those HIP 4080s. So I'm just going to, real quick, I am going to put some power to this just to make sure that I have a good functioning drive card, that no damage was caused there. My 10 amp current limited power supply. I get a lot of questions on my equipment, just a ton of questions. But it's the brick style power supply. They're really quick to shut off on shorts or overloads. They'll still supply a lot of current, as you can see. My red lead here, how it's all kind of curly cued. It's because sometimes I short it out to my power, but they're great power supplies to use for testing like this. And a good way to find out which one's positive and which one's negative without looking at the side plate, because sometimes I will have the side plate sitting pretty far away, is if you look at your power supply capacitors, they're polarized. So you have your negative side of your power supply capacitors right here. So it's on this primary trace right here, which goes to this terminal. So that's your negative. And as usual, make sure you don't have any conductive stuff underneath your mat when you fire boards up. You will get just an excellent surprise if there's a short underneath. All right, let's get some power on this thing. So I'll just connect my alligator clips here. My scope is up and running. Oh, hold on, guys. I'm going to turn the meter off. My laptop doesn't like to run my meter and the scope at the same time. So let me find it here. Raggle. And select. All right, so there's the scope. Let's see, does this thing work or not? That's going to be the question of the day. I get a blue light down there so I don't have any shorted power supply transistors. And of course, if you did, they would start to get smoking hot, but they're not hot. We should have 12 volts. Well, if I have my scope set right, we should have 12 volts. What you do, looking good. And the remote terminal. So its remote terminal is going to be the one that's not connected to your speaker leads. And I'm just going to pulse it. Oh yeah. Why is my signal looking so dirty? Yeah, and you'll see, let's see here, we want to go to 20 microseconds. All right. So as you can see here, I'm just pulsing it real quick, but the drive is building on the power supply. All right. So we do have drive. I mean, I probably could power it up fully, but let's see here. Just in case, I'm going to turn on the old thermal camera here. I just want to check and make sure my outputs are not heating up. The outputs on these use the 640Ns. So, no heat, just the rail discharge resistors are heating up. Yeah, green light and the relay comes on. So the green light comes on, relay comes on. So let's see, let's check the switching. I think this is just going to be a PCB repair, which I do. I do repair PCBs. I do fiberglass work. Yep, there's your switching. So let me get it more into view for you guys here. This looks like a typical, this must use the 2184 IC. And that's what I'm assuming. These ICs, of course, from DC are, they are ground off. You can't read them. Oh, yeah. So that's like a typical, 2184 drive. I have not seen this card before. It's too bad they do that to their ICs. I mean, I'm sure one of you guys out there could point in the right direction than that, but I'm assuming there's an 8-pin IC on this here with, it looks like your typical capacitor setup. So I'm assuming it's gonna be like a 2184 with a 311 and a 072 here. I'm assuming, of course. Hey Cliff, hey, thanks for dropping by. Yeah, I wasn't planning on being on, so I was gonna record another video and I decided just to go live instead. So this amplifier it's functional, it works. I will rebuild the drive section of the power supply. More than likely, it's really odd that someone would replace those transistors. I don't know if those resistors are original, but they left them in. That's just an odd way to do that. And this capacitor, it really is melted pretty good. So looks like they left that in. I don't know. I have a little bit more detail in my repairs than to leave stuff like that in. So, but that's this board here. So I'm going to kick this one aside, and I'm going to grab a Pioneer. I think it's a 9601 here. So this one is a power supply. PCB. Again, to get rid of that conductive PCB that's in between those drivers. So, and this is how I diagnose boards. It literally takes me probably, besides disassembly, of course, it takes me 15 minutes to really figure out what's wrong with the board. And I get this all written up and then get my quote sent to the customer. Not worth buying sending my chips. Whatever's good, it will be. Never doing a 480 after I run out. Yeah, that's true. I mean, these older amps that run those 4080s, I've got probably 7 of those left. I unfortunately I have to charge an arm and a leg for those 4080s because of how much money and time I have invested in them. But 4080 amps, they're getting a little bit more rare to get, but they're still out there. All right, so I have a Pioneer GM, it's a D9601. So let me kick this board aside real quick for you guys. And move on to the next one. Ew, look at that. That's, I don't know. My poor camera does not like that. See the lines in that picture? It drives me crazy. One day, guys, I promise you, I will have much better recording equipment. Of course, it all comes down to the dollars. Let's see here. There it is, a GMD 9601. Let's see here. These have, in my opinion, common failures. You're going to have one of two things. You're going to have shorted output transistors or shorted power supply transistors, or both. So oh, there we go. Another typical issue is the output inductors on these things. This is like free floating here, not glued down, not secured, and one of the windings have actually started to unwind off of it. So of course that needs to be secured down. But sometimes I'll have it to where these will have vibration damage, and this will short out, causing damage to the output section. So let's see here. Oh yeah, all right. So let me back up again with you guys here. And let's go over this that's it. That's a good amp. Then they restarted a few times, more smoke. Oh yes, and that just drives me crazy. If I could have a sign or a banner that's up somewhere, I would say once the amplifier quits once, don't try to restart it. Don't put another fuse in it. Don't fire it back up. Just, there's a reason why fuses blow. There's a reason, and just adding another fuse will just cost you more transistors, or worse yet, will cost you some PCB repair. My minimum charge to fix the actual PCB itself, fiberglass work, is $75. So I charge $75 per spot that I have to repair. So don't burn your boards up. It's expensive to do. Oh, like the American baseboard I just put a video on. I have spent hours on that board repairing what someone else has done, and the bill on that thing is not cheap. So guys, don't keep putting fuses in your burned up amplifiers. All right, where was I? So power supply. Let's go ahead and see what the power supply is showing us. 4.7K. So I'm checking gate to source. And then gate to drain, gate to source, gate to drain, gate to source, gate to drain. And then of course you're going to check drain and source. And if you see your number rise like that, that's charging your capacitors, which is good. You'll see that it's that number will stay at a low ohm value if there's a short. So the power supply itself is still good. It's charging the capacitors as I would expect it to be. Oh, come on, guys, clean up your flux. Gate resistors in these, in the 9601s, are 47 ohm gate resistors. And let's see here. And we're going to go to the output section here. 477 ohms. 477 ohms. 1.9K. Well, now there's telling you there's a problem right there. So, gate source, 4.7 ohms. Drain source. Oh, there you go. Drain to source, 0.18. So that's called a low ohm value. That is a direct short on the output transistor. Street clamps. Oh, Cliff. Hey, thanks. What are you doing? Oh my gosh, sent to help you with some video equipment. Oh, hey, thank you. I do have a camera. Oh, on my list, and I can't remember. It was like the Sony X1 or V1 or something like that. That I think Phil had got one, and I was pretty impressed with the picture, and the price seems pretty decent. So that is going to be my camera of choice. I just can't remember the model name right now. So we have one shorted output transistor. Let's check the others. 1.9, 0.19. So that bank, obviously, you're going to show a short. Remember, transistors do run in parallel banks. 4.7. Now that's more like it. So 4.7, and there's your capacitor charging. So one side has shorted out. Let's see here. Yeah. So this side is shorted out. I don't know if it's the high side or rail to rail or your low side drive. I'm not quite sure. My goal right now is just to determine what's wrong with it. So I'm going to take the heatsink spreader off so that I can determine what transistor it uses. So this uses the IRFB 4227s. So I'm going to replace, of course, the parallel bank. Always replace the parallel bank, in my opinion. I know some other techs don't do that, but think of it as parallel resistors. And if you do your parallel, your voltage drop calculations, you'll see that there's going to be a different voltage drop based on the value of the resistor. So it's the same thing with a transistor. You have 3 parallel transistors. Each one of these is going to have a slightly different resistance value, but between batches, you may have a significant resistance value. So you want to avoid that because you could run into thermal issues. Team No Fuse, totally nuts. Yeah, Team No Fuse. Wish we could see his face when he sees that. Yeah. So I'm going to need new 4227s. And again, I just write it down on my list on what I need. 4227s. So you know it's the output. So then you got to tell yourself, hey, you know you're going to be changing the output drive IC. It may have survived. It may not have survived. But in my quotes, in my final quotes, my final quote is my cost. So what I do is if I have shorted output transistors, I will include the price of the drive IC, which is right here, which covers me if I got to replace that IC. Because any of you guys that repair amps knows what is it like getting your drive ICs right now. A complete nightmare to get parts. I've noticed Mauser's starting to get a few parts in. Let me get this IC number real quick here. The IRS 2092. The IRS 2092. Which is another common drive IC. So good power supply, one shorted bank of transistors, and a drive IC. Probably it was a drain source short, right? Yeah, so it wasn't a gate short, right? Yeah, so it's not a gate short. You know what the good thing is if it's not a gate short, is all that current didn't pass through the gate, going back and damaging other areas of the drive IC. So when you have a drain, source drain short, it's just a short across the output. As you can think of it, you know, your positive and negative, I guess, one way to look at it. Now, if you would have had a gate to drain short, then all the output current could go right back through your gate, going right back through all your circuits over here, and really wrecking havoc on a lot of things. So knowing how the transistors have failed, or the failure mode, really helps you determine what has been damaged. So I'm probably more than likely going to have good diodes. Yeah. And probably good resistors. Yep, 10 ohms, perfect. And that is that. So no PCB repair needed on this one, just inductor, probably inductor tie down. Otherwise, simple repair. Just like that. Glad you stockpile parts. Oh, same here. I have a person that I work with overseas that is really good at finding parts for me. But there are some that I just refuse to buy right now, like the SI8244s. Now, guys, if you have any SI8244s, please, if you're willing, if you got extra and you're wanting to sell any, hit me up. I would love to chat with you. I am extremely low on the SI8244s, and the Tar Amps boards uses those. So all the Tar Amps repairs that I have that are not warranty repairs usually takes that 21844. So and they're currently $37 per IC through the overseas vendors. So super expensive. All right, and my other amp is a Tar Amps 30K, but unfortunately doesn't fit underneath this camera that I gotta get next. Oh, hold on. I'll be right back, guys. Give me 2 seconds. Let me go grab the next one. I have an MTX amp here. I'll be right back. Let me go grab it. So what I have here is stuff falling on my shelves. All right. I have an MTX. I don't even know what this is. What is this? RFL 1200D that I have been given the go-ahead to proceed. Very interesting design. I am not an MTX fan. I do turn away quite a few MTX boards because the design, the way they design their boards it's kind of like repairing some of the Rockford Fosgate boards. I just don't have the time to reverse engineer and figure out what the engineers were thinking when they designed it. So no, I will pass. But this MTX board is not like the MTX boards that have those gate drive transformers. I'm trying to think of the MTX board that I'm thinking of that I just despise working on. The Thunder? Is that what I think it is? The MTX Thunder? You did? I asked Tar Amps and they about the 21844s, and they told me they were in low supply, so they were unable to sell me any due to their lack of supply. So they're kind of in the same boat when it comes to availability of parts. I think, I don't know if they are just trying to keep it for their techs. I'm not sure, but yeah, if you got any 21844s, I am all ears. All right, guys. So I have a question for y'all. Oh, this does use the gate drive transformers. Ah, look at that. Can you guys see those? Yeah, right down in here. Right there. 2 gate drive transformers. Well, I'll be darned. What? And I think I've read this before, but I don't fully know exactly. But what? I'm assuming these are going to be the negative rail capacitors. Super common for negative rail capacitors to fail. Why is it the negative rails that fail? This is something that I have not been able to wrap my poor little brain around, is why is it typically the negative rail? The weird heat sink? Oh, yeah. I had opened this up originally, and I told the guy, you know, what's going on with it, what needs to be done, and he said, go ahead and proceed. So I do have new caps for it. Some brand new caps for it. Yep, it'll fit perfect. Arrow had these in stock. I will admit to you guys that there's sometimes where I love shopping with Arrow, sometimes a little bit more than I do with Mauser. Nothing against Mauser, sorry guys, but Arrow sometimes has a better selection of parts that Mauser may not have. And those capacitors are one of those parts. So yeah. Again, if you know why this negative rail fails like this, then please let me know. So, does anyone here, are they familiar with this board? Where is it? There's a resistor here. Yeah, I've got one resistor here next to the gate resistor. I don't think it's a pull down. I'm not sure. Because I'm not seeing a pull down for the other side. So it's got to be on the driver board. But there's a resistor here that got so hot it is completely desoldered from the board. I just don't know what it is. Oh yeah, I've got lots of 4227s. It's the SI8244s that I am in desperate need of. Transistor wise, I've got 4227s, 4127s, 4115s. I've got all the TO220 transistors. And if not to, I believe LCSC also has them. Yeah, Cliff. I'm gonna owe you one for that. Thank you, Cliff. Thank you guys for the most awesome support too. Yeah. So there. I forget sometimes that I can respond in the chat window, but my laptop is off to the side over there, so I kind of reach over. But yeah, so this has a full power supply short, and the power supply transistors. Oh, this uses screws like the tar amps. The transistors in this are not your typical everyday run-of-the-mill transistors. You know, go figure, MTX had to use something odd, but I'm thinking I can use the 3205s in this, because these use the gosh, what is that? The 75339 P channel. I think 75339P. It looks like it's a Fairchild transistor. That I think I can thanks, Fred. Yeah, I do try my best. And then it uses the 640s. This is just a really weird design amplifier. A lot has been done to drive a couple banks of 640s, in my opinion. 640s are some of the most common transistors you'll find in amplifiers. So yeah. So here we just have the negative rail. I'm assuming that's negative rail. Capacitors that have shorted. We're not shorted, but obviously they need to be replaced because they're all swollen up. They may or may not have vented out a little. They definitely have gotten hot. I don't know, due to high ripple or something of the sort. And then there's a few burnt resistors on the output drive card here. So this one will be interesting to repair. So again, if anyone knows what R63 is on this amplifier, it's the RFL 1200. Oh, RFL, yeah. RFL 12,000, or no, 1200D. Okay. RFL 1200D. That'll be my biggest hurdle, is figuring out what that resistor is. But otherwise, that amplifier is, I think, ready to come apart. All right, let me grab the board that I'm currently working on. All right. So this is what I was working on this morning. Which, let me flip this around. This is an Orion HCCA. It's a 5K. I did have one spot that had burnt all the way through the PCB that I had to do some epoxy repair on. So what I'm going to do real quick is I'm going to pull out this transistor that I have sitting here. You can see this little lone guy sitting right over here. It's a, I call them tester transistors. They're transistors that are I really don't use for anything other than placing placeholder here. When I do PCB repair. So this has one spot of PCB repair that I did. Kind of hard to see. You guys really can't see it, I guess. But right down in here, I fixed probably a 3 millimeter hole in that via right there. So I just used my a transistor as a placeholder while the epoxy set up. Just like that. And I just used a little bit of solder on the gate pin to keep it in place while the epoxy was setting up. There it is. So just a little placeholder transistor. Good old IRFP 250N. So now I have a nice, good repaired section of board there. So what I'm going to do is put some power to the power supply and see if I have a good drive signal. There's no transistors in place, so we won't have rail voltage. Probably not much is going to happen, hopefully. So we're going to go ahead and put some power to this and see what it does here. Once I remember where my power is. And then, of course, before I do that, I'm going to make sure I don't have any shorts. It's funny, at first I was reading, what was that, 1 point something ohms, because I had my power supply hooked up. So gate drain source, just making sure there's no shorts. Of course, when I start the power supply, it'll tell me if there's a short or not. And then hopefully, if all is well, this power supply is going to give me a good drive signal. A good drive, I should say. It's really not a signal, it's a drive. So these Orions use the SG3525 to drive the power supply. And it uses two IR2110s to drive the output section. So let me see if I can get this a little bit. You stay there, camera. So we'll turn on some power here. And I got a blue light, and let me get this scope. Oh yeah. Nice. So we do have gate drive. Nice. Fan works. And then, of course, the other side. Yes. So we do have gate drive. And then I just do the same process. I will make sure that I don't have any shorted output transistors, which I don't believe I do on this amplifier. There's not going to be any rail voltage, so I'm not worried about that. So 4.9K, which is correct. 4.9K. Gate to source, and then gate to drain. 11, gate to drain. It will be 11. Gate to drain. Perfect. And gate to drain. Perfect. Gate source 4.9, gate source 4.9. So really, this amp here, all it needs is some new power supply transistors, and I will bet money it'll fire right up. But that was this amp. So this is what I was working on this morning. Was doing the PCB repair on that. This burned up pretty bad, and we'll get it all put back together. What time is it? So we've been going on for an hour. Sorry guys, I hope I'm not keeping you too long here. I just wanted to go over a couple things today on this live stream, so I didn't have to record a video and then edit it and then upload it, and you know how that goes. Time consuming stuff. So again, I do thank you guys for watching. Cliff will be in touch on that 50 there. I do thank you. It will definitely anything that comes through the site here will go towards equipment. I did make, of course, over the 1,000 subscribers, so I'm starting to make a little bit of money on the channel. So I do appreciate all you guys, and I will only continue to make the channel better for you. So I do thank you for watching. Please drop on by again. If you have any questions, you can always get a hold of me directly, ellensburgamplifier.com or Facebook. I am always available. I thank you guys for watching. And again, as usual, stay safe and keep your fingers out of the rails. We'll catch you on the next one.